Hello everybody, Harry from GMAT Ninja here, and welcome back to our GRE Quant video series. In this episode, we're going to get really deep into the algebra, and we're going to go look at inequalities and absolute values. Now, for this session, I'm going to split this up into three parts. So which part is most relevant to you probably depends on what sort of score you're aiming for and how far through your preparation you are. So if you're just starting out, or you're aiming for a score, let's say up to about a 155 on the quant section, then the first four questions where we just dig into the basics and we look at what these things do, how the algebra works, and what you should look out for, those are probably going to be really helpful for you. If you're somewhere in the middle, so your score that you're looking for is maybe 165 up to 162, 163 or something like that, then the middle four questions where we look at how the GRE tests these concepts are probably going to be very helpful for you. Maybe you need some work on the basics, maybe you want to test yourself towards the end, but those ones in the middle are where you're going to get most value out of this session. Then the final two questions we're going to take a look at today are they're just gratuitously difficult. We've taken a look at what we can do with inequalities and absolute values. It's probably quite unlikely the GRE would go this far, but just because we're here, we thought we'd test things out. And if you're aiming for something in the 165 plus region, stick around, have a look at these final two questions at the end where we're really going to test your algebra skills. So as usual, I'm going to get questions up on the screen. We'll give you a bit of time to take a look at them, and then we'll come back and go through them together. The amount of time we give you per question will depend a little bit on how difficult they are. So first four questions where we look at the basics up at the start of this session, I'm going to be pretty quick. We're going to give you about a minute to take a look at these questions. Then we'll come back, and as I say, we're going to tear apart the basics and have a look at what should you focus on with the algebra and what should you look out for as they're asking the questions. So I'll get the first question up on the screen, give you a couple of minutes to take a look at this, or give you 1 minute to take a look at this one. I'll see you back here to go through the solution soon. Okay, as always with these videos, if you need a little more time to take a look at this one, now's your chance to pause it before I take that question away so that we can look at the solution together. All right, hopefully a nice, easy one to begin with. As I said, we're going right back to the basics. So if this really is elementary for you, feel free to skip ahead, and the questions will get a lot harder as we go through this session. But here, I really want to take a look at the very basics of inequalities, what we can do, what can't we do, and what we should really look out for as we're dealing with this problem. So when you're looking at inequality, most of the time, you can just treat it as an equation. There's a lot of things we can do where we could treat it almost as if this question said minus 2x plus 4 equals negative 8. Now, I'm not going to treat it like that because it's not an equal sign and there are some things we can't do. But the first thing, one of the things we can do is we can add and subtract and just treat it exactly like it was an equal sign. So if I've got a plus 4 on this side, I want to isolate the x values to find out, well, is x bigger than or less than 6 in terms of this question? So if I want to isolate this x value, I would subtract 4 from both sides, and we get negative 2x is greater than negative 12. So addition and subtraction, it works just like an equal sign. Nothing's changed there. Now, at this point, there's a couple of different paths we could take. I'm going to show you both of them, talk you through the differences, why you might prefer one over the other. The big thing to look out for when we're dealing with an inequality is multiplying or dividing by a negative number. If you're multiplying or dividing by a positive number, it's exactly the same as if it was an equation. But if you're multiplying and dividing by a negative number, we've got to be really careful. So the first thing, and probably the more intuitive thing that we might want to do, is that if I've got negative 2x here, I want to divide this by negative 2. Okay, so on the left-hand side, I'd get x. On the right-hand side, if I've got negative 12, if I divide that by negative 2, negative 12 over negative 2, we're going to get the answer in a second. But the bit that I want to focus on is this bit in between. So up here, it was a greater than. But because I've divided by a negative number, I've got to flip that inequality sign. It's just, don't worry too much about the why, that's just how the algebra works. If I multiply or divide by a negative number with an inequality, I've got to reverse that inequality sign. So we get x is less than negative 12 over negative 2. And so in this case, x is less than 6, which is going to give us the answer to this question. If in quantitative comparison, we're comparing x to 6, and we say x is less than 6, that means quantity b must be bigger, and the answer to this question is going to be b. But the first way of doing it, and probably the way that seems more natural, just because it's similar to how an equation works, is at this stage I'm going to divide by negative 2 on both sides. I've just got to remember to flip that inequality sign. Okay, the second way of doing it, as I say, less intuitive. You're probably not going to choose to do this way, but I need to get it out there as an option, is to try and manipulate things so that we can avoid dividing by a negative number. So what I could do here is if I add 2x to both sides, I'm going to get 0 is greater than negative 12 plus 2x. And then if I add 12 to both sides, I'm going to get 12 is less than 2x. Okay, now both sides are positive. But really the bit that I'm looking out for here is I've got a positive 2x. To get the x by itself, I divide both sides by 2. And I get x is less than 6. So I get the same answer I had before. Nothing's changed in terms of the answer here, but I've managed to find a way of avoiding dividing by a negative number, which means I don't have to remember to flip that equation. Whichever path you choose to take, you're going to get to the same answer, as you can see here. It really doesn't make that much difference in terms of the timing. It's just, do you think you're going to be able to remember that divide by a negative number means I need to flip the inequality sign? If you can, great, we can take this shorter route. If you can't, I'd try and do all you could to remember to move things around so I don't have to divide by or multiply by a negative number. All right, there's hopefully the basics of inequalities. Treat them like an equation, except for when you're multiplying or dividing by a negative number. That's the bit to be careful with. I'll get the next question up on the screen. We're still going through the basic bits, so I'm only going to give you another 1 minute to take a look at this one, but I'll see you back here to go through the solution soon. Okay, pause here if you want some more time on this one. All right, as we said at the start of the last question, that if you're absolutely comfortable with this, if you've flown through this question with no problems at all, feel free to skip ahead. Things are going to get harder soon. Still dealing with the basics here. And now we're looking at these absolute values. So I've got this equation. The absolute value of 3x minus 5 equals 13. And we're asked which of the following could be the value of x. Now, there's two ways of looking at this absolute value question. And just like the last problem, I'm going to look at both of them so that you've got both the options. You can deal with questions however they come at you. So the first way of looking at it, I'm going to just give this sort of general setup. So the absolute value of a minus b is equal to c. And what this really says, there's a geometric way of looking at this, a sort of in space. And this says that the gap between a and b is c on the number line. So we've got two things here, and if we wanted to know the size of the gap, then that would be c. I'm going to put that into practice now so you can see what that looks like in terms of this question. So we've got the absolute value of 3x minus 5 is equal to 13. So if I put a number line here, put 0 there and 5 there, then this question is saying that the gap between 3x and 5 is equal to 13. All right, I don't know where 3x is, but I know where 5 is on the number line. And if I figure out, so I want to make a jump of 13, that's the size of the gap, to the right, so that would take me to 18 there. And if I made a jump of 13 to the left, then that would take me down to -8 all the way down here. All right, and so the gap between 3x and 5 is equal to 13. So the size of the gap is 13. I know where 5 is, and this tells me the two options that I could have for 3x. So 3x could either equal 8, or 3x could equal 18. Then it's just a case of dealing with the simple algebra. Divide by 3 on both sides, x is 6. And divide by, 3x is -8 over here. Divide by 3 on both sides, x is -8 over 3, which is going to give us answers of D and B. So those are the two that you should have chosen for this one. So as we just said, the absolute value can represent the distance between these two values within the absolute value sign. The size of the distance is 13. You can move out from the place you know, find those distances, and then the algebra to finish with is simple. There is another way of dealing with this question that is more algebraic. So if I start with the absolute value of 3x minus 5 is equal to 13. What an absolute value does in terms of algebra is it says, well, let's look at what's inside 3x minus 5. Now, if that's positive, nothing happens. So if I take the one option, if 3x minus 5 was greater than 0, well, then the vertical brackets that you get here, you can just treat them as sort of your standard set of parentheses, and we'd get 3x minus 5 is equal to 13. Well, if I add 5 to both sides, I'll get 3x is equal to 18, and divide by 3, and x is equal to 6, which is the answer D that we got before. Okay, the other way of, well, the other side of this that we need to consider is what happens when 3x minus 5 is less than 0. Now, when that happens, the way you can deal with this algebraically is to keep what's inside the absolute value sign within parentheses, but stick a negative sign on the front. So we multiply everything within this absolute value sign by -1. Now that gives me 5 minus 3x is equal to 13. Now if I add 3x to both sides and I subtract 13 from both sides, I'll get -8 is equal to 3x, and divide by 3, and I'll get x is -8 over 3, which is the other answer we had before. So just like the last time, there's two ways of looking at this one. You can either do it geometrically or graphically using the number line, or we can go algebraically, whichever one makes you more comfortable, whichever one works better in your head. As you can see, there's no difference in the final answer, and probably no difference in how long they take. All right, that is hopefully got you up to speed with the real basics of inequalities and absolute values. We're going to start accelerating things just a little bit, still dealing with the basics. So I'm still going to give you a 1-minute chance to take a look at the next question, and we'll see you back here soon. Okay, pause now if you want a bit more time to look at this one. All right, this question's a bit more about what to look out for, what to avoid. So I'm going to give you the answer first, and if your reaction to that is, what? I didn't get that, then stick around and we'll explain what it is that you might have missed or where you might have gone wrong here. So in this question, okay, A, B, and C are integers, and we're told AC is less than BC, and we want to know which is bigger, A or B. Okay, the answer to this question is D. We just can't tell. All right. If you've got D, if you're comfortable with Y, great. Feel free to jump ahead to the next question. If you're sitting there going, I didn't get that at all, here's why. All right. If you remember back question 1 on this video, we said that the key thing to remember with inequalities is be careful when you're dividing by a negative or multiplying by a negative. It's not that you can't do it. It's that, remember, that inequality sign flips. All right. When you see this inequality, AC is less than BC, the natural thing, the thing that I want to do if I want to simplify this is I want to divide by C. But what is C? We know it's an integer, but is it positive or negative? Because if C is greater than 0, if C is positive, then I can divide by C and there's no problem at all. I've got AC is less than BC. I divide by C on both sides and A is less than B. Great, that was nice, that was simple. But what happens if C is less than 0? I still start with AC is less than BC, but now if I divide by C on both sides, I'm divided by a negative number. And as we said with question 1, divide by a negative number with an inequality, I need to flip that inequality sign round. So now A is greater than B. Well, which side is it? Is C greater than 0? Is C less than 0? And from the information we were given in this question, I just can't tell. So I know the algebra, I know where this could go, but because I don't know whether C is positive or negative or 0 for that instance, can't be 0 given what we've been told there, because if C was 0, this would say 0 is less than 0. That doesn't work. So I can get to the stage where I know C is not 0, but I can't tell whether it's greater than or less than 0, so I can't tell whether A is less than B or A is greater than B, so the answer is D. So as we said, part of this basics bit is what to look out for. If you're got an inequality and you're thinking about dividing by a variable, well, be careful. Do you know whether that variable is positive or negative? Are you confident that you know which of these two paths you're going to head down? All right. One more question in this kind of basics bit of this video. So 1 more minute to take a look at the next problem. I'll see you back here soon to work through that solution. All right, pause now if you want some more time to take a look at this one. Okay, this time I've got inequalities and an absolute value together, and now we're beginning to just think about that interaction between the two of them. First job though, I'm going to deal with this bit at the top. So we're told x squared is equal to 196, and in this quantitative comparison question, we want to know which is bigger, x or negative 14 here. Well, now this value, if I find the square root of 196, this will tell me that x is either positive or negative 14. Right, so if x is positive 14, x is definitely bigger. If x is negative 14, these two are the same thing. If I can't tell whether it's positive or negative 14, then the answer is going to be D, because I can't tell which is bigger out of these two. Okay, so that's the first piece of information sort of dealt with. We can't do anything more with that for now. I'm going to look at this second piece. So x multiplied by the absolute value of x is less than 0. Now, if you remember what the absolute value does, if x is positive, doesn't do anything. If x is negative, then it makes it positive. So I can say that the absolute value of x, that is definitely positive. We know from the beginning, that we know from before, that x is not 0. I could have told that from either of the pieces of information. X is definitely not 0, so it's definitely positive. Now, what this expression really says is I have two different things. I've got the x and I've got the absolute value of x, and I multiply them together and I get something that's less than 0. So if I've got two things and I multiply those two things together, and I get something that's less than 0, then we know that one of them is positive and one of them is negative. Because if it was positive, positive, and I multiplied the two positive things together, I'd get a positive. If it was negative and negative, and I multiplied those two negative things together, I'd get a positive. So we know the signs of these two things are different. But the absolute value, well, that's definitely positive, which means that this x value, in order to make the product of the two of them less than 0, the x value must be negative, which tells us which of the positive or negative 14 we're dealing with. From this second piece of information, we know that x is definitely negative, so x is negative 14. Which means that if we're looking at these two things, quantitative comparison question, which is bigger, negative 14 or negative 14, they're exactly the same, so the answer to this question is going to be C. All right, hopefully that's kind of broken down some of those barriers, given you some of the basics of the inequalities and absolute values that we're going to be taking a look at. I'm going to start to increase the difficulty level now. So we've been doing 1 minute per question up till now. Now I'm going to give you the standard GRE minute and 45 to take a look at these questions. So I'll get the next one up on the screen. And as always, we'll see you back here to take a look at the solution soon. Okay, pause here if you want more time for this one. Okay, this style of question, one of the first things that I might see one of my students do is that they're going to jump at picking numbers. So for A, for instance, we know it's between 0 and 1. And so I might have somebody go, well, what if A is a half? How about a quarter? We could make it a third, 3/4, 5/6, 7/8. Now, that sort of random scattergun approach to just throwing numbers at the wall and just seeing what sticks, it's rarely a good place to go. It usually means that you're not really sure where this question's going, and things don't usually end well there. I want to sort of distinguish that from selecting numbers to make a case. And you're choosing very specific numbers in order to create an argument, which is different from just throwing numbers at the wall and seeing what sticks. Right, so in this question, I would select numbers in order to make a case and think about quantity A and quantity B. That is not the sort of random number selection. And I really want to make that distinction clear because they're very different ways of looking at the question. Random number selection rarely ends well. The way that we're about to go through is a much more sort of surgical, thoughtful process that is going to get us towards an answer. So please bear that difference in mind when you're doing questions yourself. If you find yourself just going, what if B is 1.5? What about 1.6? How about 1.2? Then that's probably a sign that you need to stick a flag on this question, move on, and at the end of the section, come back to it. All right, having said that, let's take a look at this problem. Now, as you said, I don't know what A is. I know it's between 0 and 1, but I don't know what it is. Same with B. I don't know what B is. I know it's between 1 and 2. I don't know what B is. So what I'm going to do here is on both sides, quantity A and quantity B, I'm going to look at what's the biggest they could be, what's the smallest they can be, and just see if I can get any information from that. So I'll look at this left-hand side first, quantity A, and so I want to, first of all, I want to make AC as small as possible. Now, the first thing I'm going to do is I'm going to select a value of A in order to do that. Now, A is bigger than 0. So what I'm going to do is I'm going to make A basically 0. I know it's not. A is not 0. It can't be 0. A must be bigger than 0. But if I say that A is 0.0 and I just keep drawing zeros for a while, it's so close to 0 that it doesn't really matter in terms of the arithmetic. So if I say that A is approximately 0, it's not, but approximately 0, and C, if I make that as small as it possibly can, by the same argument, I can say that C is basically 2 if I make it as small as possible. So the smallest that AC could be is 0 multiplied by 2, which is 0. Now, I know it's not 0. It's going to be slightly above, but it's going to be so close to 0 that it doesn't really make a difference. Now, if I go to the other end, if I want to make AC as large as possible, then same argument as before. A, it's not 1. It can't be 1, but it can be so close that it might as well be 1. I could just keep drawing 9s. That's making A as big as possible. And so I could say that A is basically 1 if I want to make it as big as possible. Same argument, C is going to be basically 3. So A multiplied by C is 1 times 3. That's going to be 3. So AC is going to be somewhere between 0 and 3. All right, doing the same thing over here. The smallest that B squared could possibly be is when B is as small as possible. In this case, same argument that we've had before. I'm not going to go through that again. But if B is basically 1, then the smallest B squared could be would be 1. By the same token, the largest B squared could be is when B is as large as possible. I'm going to make B as close to 2 as I possibly can. So I'm going to approximate it to 2. So B squared is going to be 4. Well, B squared's approximately 4, or B squared is somewhere between 1 and 4. All right, so AC is somewhere between 0 and 3. B squared is somewhere between 1 and 4. If I drew that out on a number line, then my AC value is going to be somewhere between 0 and 3. B squared value is going to be somewhere between 2 and 4. I've got this overlap. So if B squared is small and AC is big, then AC is bigger. If B squared is big and AC is small, then B squared is definitely bigger. There's an overlap, so there's a possibility they could be the same. So in this question, I just can't tell. So the answer is going to be D. All right. I know that it looks like there's a lot going on here, but if you understand this concept about if I make A as small as possible, it's basically 0, then this gets a lot faster and I can jump very quickly to AC is somewhere between 0 and 3, B squared is somewhere between 1 and 4, and we can get to the answer being D here. As I said, I really want to make the distinction here between just throwing numbers at it. A could be, what if A is a half? What if A is 3/4? What if A is an eighth? And as we've done here, well, let's see, what's the smallest they could be, what's the biggest they could be, and does that tell us anything? Because as you see here, once we get that information, we can very easily see the answer is D. All right, I'm going to get the next question up on the screen, another minute 45. I'll see you back here to look through that solution soon. All right, pause this now if you want a bit more time to take a look at this one. I'm not going to pull this question away. All right, as we were writing this question, as we were getting this video set up, I think we came up with about 4 or 5 different ways of solving this question. So I'm going to show you one way for this video, but if you've got a different method, fantastic. Feel free to stick it in the comments. That the more different routes you've got through problems, the more flexible you can be, and that's really rewarded in an exam like the GRE. So please don't worry if your solution was different to this. As long as the algebra works and you're comfortable with what you're doing, it's great. It's great that we've got a bit of variety here. All right, so I'm going to start with the question we've been given. T divided by the absolute value of t is less than t. Okay, I'm not actually going to do anything with this to start with. I'm going to look at this bit down on the bottom of the fraction on the left-hand side, the absolute value of t. And I'm going to do something very similar to the algebraic route we did with question 2, with the absolute value of 3x minus 5 equals 13, question 2 from the video. Right, what we said then was, if what's inside the absolute value sign, in this case t, is greater than 0, then the absolute value sign doesn't really do much. It's almost redundant. And so we could just write this as t divided by t is less than t. All right, if that's a little bit confusing, think about what happens if I said the absolute value of 2, well, that's just 2. And the absolute value of 17, well, that's just 17. If what's inside the absolute value sign is positive, then the absolute value sign doesn't really do anything. It's only when what's inside the absolute value sign is negative that we really see a change here. Okay, so that's all we've done here. We said that, okay, if t is greater than 0, then the absolute value sign isn't really going to do much here, and so the left side just becomes t over t. Well, t over t we can simplify down to just being 1 over 1, but that's just 1. So in this case, if t is greater than 0, we know t is greater than 1. All right. Now the danger comes if t is less than 0, then what we said we can do is to take what's inside the absolute value sign and put a negative sign before it. All right, we might, if there's multiple terms, you might need parentheses, but here doesn't really matter. So I've got t divided by negative t. Sorry, that shouldn't be 0, that should be t. T divided by negative t is less than t. Right, just like we did over here, I can cancel out the t's on the top and bottom, and I've got 1 over negative 1 is less than t, and so 1 divided by negative 1, that's just negative 1. So t is greater than negative 1. I also know that, well, I've assumed that t is less than 0, and so if t is less than 0, then t must be between negative 1 and 0. Now the point with this question is, I don't know which path I'm going to take. If t is greater than 0, then t is greater than 1, and so quantity b would be bigger than quantity a. But if t is less than 0, then t would be between negative 1 and 0, and quantity a would be bigger than quantity b. I don't have any information here that tells me which of these two paths I'm going to go down, so I can't tell which is bigger, so the answer here is going to be D. All right, like I said, there's one way of doing this problem. I'm sure there are others. There are many others. So if your method was different, wonderful. As long as it gets you to the answer and you're comfortable with the algebra, that's great. All right. So up till now, if you've been aiming for something up to maybe 155, 156, 157 on the quant section, you've understood what we've done so far, that's probably all you need. Okay, we're going to keep sort of slowly ramping the difficulty level up. Next two questions are going to probably be in that sort of 155 to 160 range, maybe 161-ish range. And then the final two questions, we're going to stretch things significantly. So as I say, anything up to a 155, you've probably seen more than enough. If you're aiming for anything more than that, let's keep going. Another minute 45 on the clock. I'll get the next question up on the screen. We'll see you soon. All right, pause this here if you want a little more time to look at this one. I'm going to take this question away so that we can work this one together. All right, I'm going to use a similar principle here that we used a few questions back. When I get an inequality like this, x is greater than 14p, y is less than 9p, and I'm going to use it at some point in the question, I like to consider what happens as I push x as close as possible to that inequality. So just like a few questions back when we said x cannot be 14p, it's greater than it. But let's say, well, it's as close as possible to it. And so let's just approximate what happens if x is 14p. And in a similar way with y, I'm going to approximate what happens when it is 9p. Right, when I do that, now I can start to compare quantity A and quantity B here. So x minus y divided by 5, if x is, and it's not, but we're approximating it, if we approximate x at 14p and approximate y at 9p, then 14p minus 9p is 5p, and divide that by 5, we're going to be left with p. So if x was 14p and if y was 9p, then these two quantities are going to be the same. All right, at this point in the question, there's two ways you can go. There's the sort of the logic your way through it, which we'll do first, and then there's the algebra where you can justify what the logic tells us. So as we said, if x was 14p and y was 9p, then this whole thing turns out to be p. But we know that x is going to be bigger. So ignoring y for, well, holding y steady for now, if y and 5 stay the same and I make x bigger, then this whole thing will be bigger, and so we'll end up with something bigger than p. Right? But at the same time, we're going to make y smaller. So if I assume we hold x steady, if I keep x the same and take away something smaller, then the outcome, the top of that fraction, would get bigger, and so the outcome would get bigger. And so I'm doing both at the same time. I'm making x larger, I'm making y smaller, still dividing by 5. But if I make x larger and y smaller than what we started with, the outcome's going to be bigger than p, and so quantity A is going to be bigger. So the answer to this question would be A. So if you can see that, if you can sort of logic your way through it and get to that answer, great. We can get there in the way that we've just done. It doesn't take that long. We're out of here. Right? If you want to justify that at this stage, yeah, we can go ahead and do that. So now, again, I'm not just randomly choosing numbers. I'm going to select them in order to make the case. If I say, well, what happens now if I say x is 20p, which is bigger than 14p, and y is 5p, which is less than 9p, and put them back into x minus y over 5, well, 20p minus 5p, that would give me 15p, and if I divide that by 5, I've got 3p. Okay, 3p is going to be bigger than p, and so the answer here is going to be A. All right, so as I said, there are a couple of different ways through that one. I would probably do the algebra at the beginning, just as I say, when I get some inequalities like that, I like to push the x and y value as close as they can to that inequality to see what happens, and then we can logic our way through it from there. All right. Now, yeah, we're starting to make these inequalities absolute values pretty tough now. All right. Next question, we're going to sort of break past that 160 barrier. It's probably heading up towards 162, 163, 164. These are starting to get hard. So let's say if you're aiming for anything up to a 160 and you've kept up with what we've done so far in the video, fantastic. You're probably absolutely fine. Now we're beginning to start to stretch things. So I'll get the next one up on the screen. Another minute 45 for you to take a look at this one. I'll see you back here soon. All right, pause here if you want some more time looking at this one. All right, similar starting point to the last question. We've got this p is greater than 0, q is less than -2 here. There's a bit more going on in quantity A and quantity B here, but the principle behind this one, or at least the start point, is going to be very similar. If I've got inequalities like this, I want to see what happens as I push the inequality as close as possible. In this case, p is greater than 0, q is less than -2. I want to push p as close as possible to 0 and q as close as possible to -2 just to see what happens. There must be some reason those numbers were chosen in the question, and so I'm going to try and find out why. Okay, so if I make, in exactly the same way we've done throughout the video, if I make p approximately 0 and q approximately -2, p is going to be ever so slightly bigger than 0, q is going to be ever so slightly smaller than -2. They're close enough. We can treat them that way for the purposes of what we're about to do. And so in that case, quantity A is going, p times q is going to be 0 times -2. It'll just give us 0. Quantity B is going to give us q plus the absolute value of pq. Well, we just said the absolute value, well, pq we know is 0, so the absolute value of 0 is just 0. Q, we're saying, is basically -2. So in this case, pq is going to be bigger than q plus pq, and so we'd be looking, if that was all we did, I should probably rub that out. In this case, A is going to be the bigger value there. We don't have an answer yet, and that was probably premature writing A there. From this scenario, quantity A would be bigger. All right, then it's a case, well, let's think about what happens as we vary the values a bit. Now, in this case, I don't want to vary both of them too soon. That's going to get confusing. I'm going to deal with one of them first. If I need to, I'll vary the other one. So I'm going to hold q very close to -2. Again, it's going to be slightly smaller, like -2.0000 with a few more zeros once. So it's basically -2. But let's make p really big. 100, 200, 500. P's going to be big. So let's say P's going to be 500 and Q's basically going to be -2. All right, in that case, quantity A, P times Q, for 500 times -Q is going to be something very small, -1,000. All right. Quantity B, though, well, Q is still -2, but I'm going to add on, Q plus the absolute value of PQ. Q is still -2, but I'm going to add on the absolute value of P times Q. Well, we know that P times Q is -1,000. The absolute value of that is going to be 1,000. And so that'll come out, it'll be something big, in this case, 998. So from this scenario, quantity B is bigger. All right, so I've come up with two scenarios that stick with what, well, they're in line with what the constraints on the question said. I know I've been a little bit hand-wavy over here. We're saying P is almost 0, Q is almost -2. But like I said before, if you make it P just a little bit bigger than 0 and Q just a little bit smaller than -2, then quantity A comes out on top. If I just keep Q the same and make P really big, quantity B comes out on top. Different things would happen if I held P the same and varied Q, or if I varied both of them, but I don't need to get into that. I've got one scenario where quantity A is bigger, one scenario where quantity B is bigger. I can't tell which of them is going to be the bigger one at all times, so the answer here is going to be D. All right, so as I said, I'm not just randomly picking numbers there. I'm being very selective about which numbers I choose and why in order to make a case. Almost to the point where you don't really need to pick numbers at all. It's more just about logicking your way through this. P and Q are really small here, Q's really small, but P's really big. That sort of thinking gets you through these problems far more smoothly than just, well, what if P's 7? How about 12? How about P if 1? P's a half. Stay away from that. It often leads you down bad paths. All right, those are all the sorts of questions that we have close to examples for on the GRE. Final two questions of this video, as we said at the start, they're just going to be gratuitously difficult. If you're aiming for anything up to a 160, please you're probably done from here. If you're aiming for 165 plus, or if you really, really want to stretch things, then stick around for these last two, and we'll sort of see where the GRE could go with inequalities and absolute values. Because these are hard, I'm going to give you a bit more time for these questions. We'll get 2 minutes up on the screen, give you a chance to take a look at these, and I'll see you back here soon. All right, pause here if you want a bit more time to take a look at this one before I take that question away so that we can get to a solution together. All right, this question, there's not going to be too much algebra, but this is just, you're getting at the conception. Do you really understand what absolute values are doing here? So let's start to take these two pieces of information that we get given at the top and break them down. Later, I'm going to see how they relate to quantity A and quantity B. So we start with this. The absolute value of 3m is equal to the absolute value of 5n. Okay, I know at this point we've got positive here, but I kind of want to know what the relationship is between 3m and 5n without those absolute value signs. Now at this stage, if I'm just using this one, I don't know anything more than 3m is equal to plus or minus 5n, and that covers every eventuality. Right? If both 3m and 5n are positive, then great, positive. If both of them are negative, then the negatives would cancel out and 3m would equal positive 5n. If the signs are different, if one of them's positive and one of them's negative, then 3m will equal negative 5n. I just don't know at this point. All right, that's where I need to bring in this second piece of information. So we know, or we're told, 3m minus 5n is equal to 24. Now, if 3m is equal to 5n, then 3m minus 5m is the same as 3m minus 3m, which equals 0. But that's not the same as 24. So we've got a bit of a contradiction here. We can't have 3m equal to 5n and for this, what we were told at the start, to work. So in other words, 3m does not equal 5n, which means that we're left with the negative. So we know from this that 3m is equal to negative 5n. Right, now I can start to think about what's going on with quantity A and quantity B here. If I look at what's inside quantity A there, 3m plus 5n, well, as we said, 3m is equal to negative 5n, so that 3m is the same as negative 5n, but then I add on the other 5n, well, that's going to equal 0. Now I'm taking the absolute value of this, but the absolute value of 0 is still just 0. So quantity A is 0, all right? Quantity B, we could go through a load of algebra, find out what m and n are separately, multiply m by 3, multiply n by 5, put them into the absolute value signs, add them together. We could get an actual number at this. But in terms of the GRE, in terms of what we want to do, I want to get out of this question with as little work as possible. So what I'd probably say here is we know that these things are non-zero because we're going to put them together and get 24 out of here. If they were both individually, if they were both 0, then 0 and 0, we'd get 0. We know that they are not 0, and an absolute value sign, because of this, I know that I've got a positive number there, and I know that I've got a positive number there. And so if I add these two things together, I don't know what it's going to be at this stage, but I know it's going to be greater than 0, which, because this is a quantitative comparison question, is enough to say that quantity B is going to be bigger than quantity A, and so the answer to this question is going to be B. Now, you could go through the algebra and you can figure out what m and n are. That's probably unnecessary to get through this question. And I know we said these are gratuitously difficult and beyond what the GRE could ask you, but if you end up in a scenario like this in the GRE and you could figure out the answer to this sort of QC question without doing that extra work of finding out what m and n are, I'd probably take that option. I wouldn't go through the extra algebra to get to those answers. If all you're doing is learning the content and you fancy doing that to figure this question out, then go for it. But in the exam, I'm looking for the most efficient path. All right, we've got one more question for you, another tough one. I'll give you another 2 minutes to take a look at this one. See you back here soon. All right, for the final time today, if you need some more time to look at this one, now's your chance to pause this video. All right, as we said a couple of questions ago, that these final two are going to be tough. So please, if you are struggling with this question, please don't worry. Unless you're aiming for like a 169 or a 170, you don't need to be hitting questions like this. This is probably beyond what you're going to see on the GRE. But as we said at the start, I want to stretch things right from the basics right at the beginning all the way up to the really tough stuff at the end. And here we are at the tough stuff on the final question. All right, so what's going on here is I've got this string of inequalities. A is less than X, is less than Y, is less than B. I don't know how close or how far apart these things are, but I know that at least I know which order they're in as we're going from smallest to biggest. Don't know about positives or negatives. Might affect things, might not at this point, I don't know. Second line, well, this tells me that the distance between Y and A is smaller than the distance between X and B. Right, remember back to earlier in the video, we were saying that what's inside the absolute value sign, if we've got a setup like this, y minus a, then the absolute value sign tells us the distance between y and a on a number line. And in this question, what I'm looking for is which is bigger, absolute value of x minus a, absolute value of x minus b. This is another one where there's not a huge amount of algebra to deal with, but if you can conceptually see your way through the question, we can get to an answer with relatively little working. And so I'm going to start with this second line. Y minus a is less than, well, the absolute value of y minus a is less than the absolute value of x minus b. All right, now if I look at this left-hand side in particular, if you notice that x is lying between a and y. So if I say that this is the distance between a and y, then what we can say is the distance between x and a is less than the distance between y and a, because x is somewhere between a and y. X might be really close to y, it might be really close to a, we don't really know, but what I can say is the distance between x and a is less than the distance between a and y. Well, now that I've got this inequality set up, I've kind of finished the question. Because, okay, I've got this bit in the middle, but if as I follow the string of this inequality, I can say that the absolute value of x minus a, okay, it's less than y minus a, but it's also less than the absolute value of x minus b. So the absolute value of x minus a, if I collapse these inequalities and basically cross out this middle bit, is less than the absolute value of x minus b, which is what I've got in quantity a and quantity b. And so we can jump relatively quickly to an answer here. Quantity b is going to be bigger than quantity a from the inequality we've just derived, and so the answer here is going to be b. So like I said, that if you can see the concept here and see that link between the absolute value sign representing the distance that we spoke about earlier, then you can relatively quickly jump, using the first line, jump to an inequality that gives us the answer. There is a much longer algebraic way of doing this, but I'm going to leave this one there that we can stick with the conceptual way of looking at things that gets us to an answer relatively simply. All right, so as I just said at the start, this question, I hope that we've taken things from the very basics of inequalities and absolute values right the way up to the really difficult stuff on the end. Please pay attention to when we were talking about the difficulty levels there. Like I say, if you're aiming for something under a 160 and you're concerned about this question, you really don't need to. This is a way beyond the sorts of things you would need to be getting, maybe even up to a 165 plus there. That sort of question is really the tough stuff at the end. So we did the basics at the beginning. Right in the middle, there was a bit of everything where we looked at how the GRE could approach inequalities and absolute values. And then we've got these two questions at the end where it's almost like, for those of you that really want to challenge, we wanted to stretch things there. All right, I hope that's been helpful, everybody. Thank you for watching, and we hope to see you back here at another one of our videos very soon.